Right, so here we're going to do the 5B solution. This is a very tricky one, but quite useful. Get the user to enter a number and do the following. There's only a high and super high because it's actually quite a tricky one. So get them to enter a number and do the following. So let's get them to enter a number. So obviously we're going to get them to enter an integer, because I should have said that, but that's what it is. Print out all the factors of a number. Okay, so if you don't know what a factor is, but you should do, it's a number that multiplies into it. Okay, so we're going to do a loop. Let's do for I. We're going to do, and the loop should go up to the number plus 1, because it won't do the number. So if I print out I now, you'll see what this does. So if I write the number 10, I'll bring it over here, and it prints 0 to 10. Okay, but we want it to go 1 to 10. So I'm going to put 1 there. And then we print it. So now it's going to go 1 to 7 because I typed 7. Now what we need to do is check if each of these multiplies into 7. If it does, then obviously it's a factor. So what we do is we go if num mod I is equal to 0, that means there's no remainders. So if we divide the number by I and we get no remainders, and that's what mod gives me, it gives me how many would be left over if this was a division. So for example, 9 mod 4 is equal to 1. Because if I divide 9 by 4, I'm going to get 2 remainder 1. Okay? So this is kind of tricky by concept, but actually that is all the answer you need for that, really. That is actually it. So if we put the number 10, we're going to get 1, 2, 5, 10. There you go. If we put the number 1256, then you're going to get those. It's not as many as you think. You always think there's going to be loads and loads and loads, but there's not as many as you think when you do these. Look, you've only got those numbers multiply in. Let's do a big number. There we go. Wow, there's so few numbers. Well, what are the odds on that? Like, that must be nearly a prime. But it's not. So let's do a really big number. Oh, you've got quite a few numbers now. And the computer's starting to really slow down as it works out if this is oh, how do we go start numbering? Oh my god, that number's massive. Okay, well, I'm going to stop. Anyway, get the gist. It starts to take a long time. Mod is not a quick function because it has to do a lot to work something out. But anyway, so there you go. That does the high. And actually, in really super high, I put that, but it isn't actually ridiculously difficult. It just says if the number is a prime number, then after the loop say so. So we need to count how many of these happened. If only 2 happened. So we start with 0, and then we're going to do a new line. And we're going to increase count by 1 if we find a factor. And then if count is equal to 2, so we found 2 factors, then print prime. So let's enter a prime number, 13, prime. Enter a non-prime number, 20, no prime. So basically that's just working out how many factors. It wasn't ridiculously difficult to add the super hard, but in fact that was probably the harder bit, but I felt like this needed to be explained. It's quite good for working out if a number's even, because for example if they enter a number, and if the number mod 2 is equal to 0, that means if we divide it by 2 and get nothing, then it's even. Otherwise, it's odd. So that's quite a handy, and then you enter like 7 and you're going to get odd. Because that, obviously the result of 7 mod 2 would be 1, because when you divide 7 by 2, you get 3 remainder 1. Okay, so that is how you do it, and that's the answer to that one.